Now refining of metals. So here we have an image representation of electrolytic refining. So what is electrolytic refining? So it is used to purify impure metals. In this process, the impure metal is made up of anode and a thin strip of copper. As you can see, anode has that impure metal, and the pure strip, a very thin strip of pure metal, it is made cathode. So now the solution of salt of the metal that has to be purified or refined, it is used as an electrolyte. On passing the current, pure metal from the anode dissolve into the electrolyte, and an equivalent amount of pure metal from the solution here will start depositing on the cathode. So let us have a look at the definitions. So with the time, the cathode start becoming thicker as the metal starts depositing over there. So it starts becoming thicker. So there are two types of impurities in this solution: soluble impurities and insoluble impurities. So the soluble impurities will go into the solution, whereas the insoluble impurities will settle down at the bottom of the anode, which is also known as anode mud. Here we can see this one is insoluble impurity and it is being settled down. So now I have a question for you all. So the first question is mineral. What is mineral? So mineral is, like we read it in our previous slides. Mineral is naturally occurring substance, naturally occurring compounds of elements are known as minerals. So like naturally occurring inorganic element or compound, so it naturally occurs. In the earth's crust. Now, what is ore? So, the mineral from which element can be extracted easily and profitably, it is called as an ore. Gangue, I told you that this is an important term. So, what is gangue? The impurities present in ore such as sand, rock, etc. It is known as gangue. Now name two metals which are found in nature in the free state. Hint, these are of low reactivity. So what could you possibly think of? Like, what could be these two metals? So these would be gold, silver, maybe copper. Now, what chemical process is used for obtaining a metal from its oxide? The chemical process which is used for obtaining metal from its oxide, it is called as reduction. And some suitable reducing agents depending upon the metal that has to be extracted. Some suitable reducing agents are used in this process. Now, corrosion of iron. So, we have three test tubes here. Here we have air and water, and we have rusty iron nails, whereas here we have air and some oil layer which is being dissolved in the water, and the water which we have here is boiled distilled water. So it is boiled to remove any dissolved air present in it. Now in the third test tube, see, we have dry air and an anhydrous calcium chloride. So basically it is a drying agent. So what can you observe from this experiment? So it says that iron nails rust in test tube A, whereas they do not rust in test tube B and C. So what was the reason that so here the oil prevented these nails from rusting, and here this drying agent prevented uh, iron nails from being rusted. So how can we prevent corrosion? So it can be prevented by painting the iron substance, painting, oiling, greasing, galvanizing, chrome plating, anodizing, or making alloys. So these are few methods that you should remember. How can we prevent corrosion? So the galvanized article, it is protected from rusting even if the zinc coating is broken, because zinc is more reactive than iron, so it gets corroded first, and hence it further protects the iron from corrosion. Now, what is galvanization? So it helps us to protect steel and iron from rusting by coating a thin layer of zinc on its surface. So suppose we have a metal rod here, iron rod here, and we have applied a thin layer of zinc over here. So now it will prevent our original iron rod from corrosion. Because I told you the reason in the previous slide, zinc is more reactive than iron, so it will react first with the air and whatsoever the elements are that are responsible for corrosion. So it will react with them first, and hence it will protect the iron. Now, what is alloying? Process of mixing a metal with other elements to give them the desirable properties. So sometimes we have to, like, we want some desirable properties in certain elements, so we mix some metals with other elements to get them. So this is a perfect definition of an alloy. An alloy is a homogeneous mixture, that is it is like they are mixed perfectly. It is a homogeneous mixture of two or more metals, or a metal and a non-metal. It has not necessarily to be the mixture of two metals. It can be of a metal or a non-metal, and if one of our metal is mercury, then the alloy is called an amalgam. So here is one of the properties of the alloys. So the electrical and thermal conductivity of an alloy is less than that of the pure metals. Even the alloys helps prevent the corrosion. Brass, it is an alloy of copper and zinc. So bronze is a mixture of copper and tin, and they are not very good conductors, whereas solder, it is mixture of lead and tin, and it has a low melting point and used in electrical circuits. So the pure gold that is found, it is of 24 carats. It is very soft and it is not suitable for making jewelry. So now we use 22 carat gold. It is generally, you must have heard, like 22 carat gold is used for making jewelry. So it is an alloy of gold where 22 parts of gold are alloyed with 2 parts of either copper and silver. So that is how 22 carat gold is made. So we must all have heard about the Qutub Minar. So it was built around 1600 years ago. So and it has some iron pillars. So they developed a process which prevents rusting in that iron, because the rusting and the corrosion, it makes our metal weak. So the iron pillar, it is still intact and has not corroded even after such a long time. Now, I have a question for you all. Metallic oxides of zinc, magnesium, and copper were heated with the following metals. In which case will you find displacement reactions taking place? So, suppose we have zinc here. So, for zinc, the metals lying above in the reactivity series, then zinc will displace it. For magnesium, only potassium, sodium, and calcium can work. And whereas for copper, any one of these, even carbon, can act as a reducing agent. Or in for the as far as displacement reaction is concerned, so any one of them can be used for displacing the copper. Which metals do not corrode easily? So again, it has to be those metals that lies at the bottom of the reactivity series. So think about it. So those metals could be platinum. It doesn't corrode easily. Gold. Now, question 3. What are alloys? So we saw the definition, proper definition of alloys in the previous slide. So you have to remember that statement. So alloys are combinations of metals and metals, or metals or non-metals, homogeneous mixture. You have to mention this thing, homogeneous mixture. This is very important. So certain metals or non-metals can be added to metals in specific ratios to form alloys, to confer certain properties to metals, or strengthen some of their properties. So basically, to get the desirable properties. Example of alloys we saw were brass, bronze,